The idea that Earth is formed by thin air may sound paradoxical, yet this notion underscores the vital role of the atmosphere in nurturing and sustaining life. The atmosphere acts as a complex system that influences climate, supports life, and interacts intricately with geological processes. It's not merely a passive layer of gases, but an active participant in Earth's dynamic ecosystem. From regulating temperature to cycling nutrients, the atmosphere is involved in nearly every aspect of the Earth system. Without it, Earth would be a barren, inhospitable rock, similar to many other celestial bodies in the solar system. Its presence is a delicate balance that has been maintained over billions of years, allowing life to evolve and flourish. Understanding the atmosphere's multifaceted roles can deepen our appreciation of its importance. And as we explore each of these functions, it becomes clear that the atmosphere is a crucial element of Earth's ability to support life. Despite its apparent robustness, the atmosphere is remarkably fragile. Human actions are now challenging this balance, threatening the atmosphere's ability to perform its vital functions. As we delve into its roles, we must also consider our responsibility to safeguard this precious, life-sustaining layer of gases. The atmosphere serves as Earth's protective shield, a vital barrier against external threats from space. One of its most critical functions is to protect life from the sun's harmful ultraviolet rays. The ozone layer, situated in the stratosphere, plays a crucial role by absorbing and scattering the majority of these UV rays. Without this layer, the surface of the Earth would be exposed to intense radiation, making it virtually impossible for life to survive. In addition to shielding against radiation, the atmosphere protects the planet from meteoroids and other space debris. As meteoroids enter Earth's atmosphere, they encounter friction and heat, causing them to burn up before reaching the surface. This process prevents frequent bombardment by celestial objects, which could cause significant damage to life and landscapes. The atmosphere's ability to act as a protective blanket is indispensable for maintaining the stability of Earth's environment. Human activities have led to the depletion of the ozone layer, particularly due to chlorofluorocarbons, which has raised concerns about increased UV exposure. Efforts such as the Montreal Protocol have been successful in addressing some of these issues, underscoring the importance of global cooperation in preserving this vital component of our atmosphere. The atmosphere's ability to support life is most evident in its provision of oxygen and the regulation of atmospheric pressure. Oxygen, a critical component of the atmosphere, is essential for the respiration processes of most living organisms. It constitutes about 21% of the atmosphere and is continually replenished by photosynthetic activities of plants and other organisms. This balance between consumption and replenishment is vital for sustaining the diverse life forms that inhabit the Earth. The atmosphere also maintains the pressure necessary for liquid water to exist on the Earth's surface. This pressure is crucial because water, in its liquid state, is indispensable for all known forms of life. The atmospheric pressure allows water to remain in its liquid form, which supports the water cycle and enables ecosystems to thrive. The presence of clouds and precipitation is a direct result of atmospheric processes, which regulate the distribution of water across the planet. The atmosphere's life-supporting functions are intimately linked to its composition and structure. It is imperative to understand and preserve these functions to ensure the continued health and sustainability of life on Earth. Climate regulation is one of the atmosphere's most critical roles, primarily achieved through the greenhouse effect. This natural process involves greenhouse gases like carbon dioxide, methane, and water vapor trapping heat from the sun, keeping Earth warm enough to support life. Without the greenhouse effect, our planet would be too cold, with an average temperature of about -18 degrees Celsius, rather than the current 15 degrees Celsius average, which is suitable for most life forms. The atmosphere's ability to redistribute heat and moisture through global air currents also plays a significant role in regulating climate. These currents, driven by the uneven heating of Earth's surface, help balance heat distribution, reducing temperature extremes between day and night and across different seasons. Climate regulation by the atmosphere is not just about temperature control, it also involves moderating precipitation and weather events. By influencing the formation and movement of clouds and storms, the atmosphere plays a key role in determining regional climates and weather patterns. However, human activities have intensified the natural greenhouse effect, leading to global warming and climate change. This underscores the importance of understanding and managing our impact on the atmosphere to mitigate adverse effects on global climate systems. Section 5. Geological influence through weathering. The atmosphere plays a pivotal role in geological processes, particularly through weathering. Weathering is the breakdown of rocks and minerals at Earth's surface through the action of atmospheric agents such as water, air, and biological organisms. This process is essential for soil formation, nutrient cycling, and the creation of various landforms which are critical for sustaining life and ecosystems. Chemical weathering, for example, involves the reaction of atmospheric gases like carbon dioxide with minerals, leading to the formation of new compounds. Physical weathering, on the other hand, is driven by temperature changes and moisture, causing rocks to fracture and break apart. The atmosphere contributes to these processes by providing the necessary conditions such as temperature fluctuations and precipitation. The products of weathering are transported by wind, water, and ice, leading to the formation of sedimentary layers and new geological features. These processes help shape Earth's diverse landscapes, from mountains and valleys to riverbanks and coastal regions. The atmosphere's role in weathering and erosion is fundamental to the ongoing transformation of the planet's surface. Section 6. Evolution of Earth's atmosphere. The evolution of Earth's atmosphere is a fascinating journey that spans billions of years, marked by dramatic changes in composition and function. In its early days, the atmosphere was primarily composed of hydrogen and helium, remnants from the solar nebula. However, these light gases were soon lost to space, and volcanic outgassing began to shape a new atmosphere rich in water vapor, carbon dioxide, and nitrogen. As Earth cooled, water vapor condensed to form oceans, which played a critical role in further atmospheric evolution. The rise of photosynthetic organisms, particularly cyanobacteria, around 2.5 billion years ago, marked a significant turning point. These organisms transformed the atmosphere by producing oxygen as a byproduct of photosynthesis, leading to the Great Oxygenation Event. This increase in oxygen levels enabled the development of more complex life forms and set the stage for the biodiversity we see today. Throughout its history, Earth's atmosphere has been shaped by interactions between geological processes, biological activity, and external influences, such as impacts from celestial bodies. In recent times, human activity has become a dominant force in atmospheric evolution, presenting new challenges and necessitating a deeper understanding of the atmosphere's past to inform strategies for its preservation and future stability. Section 7. Fragility of the atmosphere. A comparison with Mars. The fragility of Earth's atmosphere becomes starkly evident when compared to that of Mars. Mars, once thought to have a thicker atmosphere similar to early Earth, has lost most of its atmospheric gases due to solar wind stripping. This loss, coupled with its weaker gravitational pull and lack of a magnetic field, has left Mars with a thin atmosphere composed mostly of carbon dioxide, incapable of supporting liquid water on its surface. Mars' current atmospheric state underscores the importance of Earth's protective mechanisms, such as its magnetic field and strong gravitational force, which help retain its atmosphere. The comparison with Mars highlights how delicate and uniquely favorable Earth's atmospheric conditions truly are. Without a sufficient atmosphere, Mars experiences extreme temperature variations and lacks the ability to sustain life as we know it. This serves as a cautionary tale, reminding us of the potential fragility of our own atmosphere and the need to protect it from threats such as climate change and pollution. Understanding the differences between Earth's and Mars's atmospheres provides valuable insights into the factors that make our planet habitable. Section 8. Conclusion. The importance of protecting our atmosphere. In conclusion, Earth's atmosphere is a remarkable feature that plays a crucial role in making our planet habitable. From acting as a protective shield to supporting life and regulating climate, the atmosphere is integral to the functioning of Earth's systems. Its influence extends to geological processes, highlighting its comprehensive impact on the planet. Understanding these roles underscores the importance of preserving this vital component of our environment. As we face challenges such as climate change and pollution, It is imperative that we take action to protect and sustain our atmosphere. Global cooperation and informed policies are essential to address the human activities that threaten its integrity. Protecting our atmosphere is not just about ensuring a stable climate and clean air. It is about safeguarding the future of life on Earth. By understanding the intricate roles of the atmosphere, we can better appreciate its value and the urgent need to act as stewards of this precious resource. Our actions today will determine the health and sustainability of our atmosphere for generations to come.